Hello viewers, welcome you all. In today's lecture, I'm going to take up some questions related to the topics that I have covered in the earlier lecture. You know very well that in earlier lecture, I have covered two topics of nuclear physics, and the topics were radioactivity and nuclear decay process, right? So in today's lecture, I will take up some questions which are asked in different competitive exams related to these two topics. But before going to the actual topic, I want to answer some questions of the students, right? That has been raised. The first question was that you know in how much time I will finish these coaching classes, or how much syllabus I will cover. So I want to tell you very clearly that these coaching classes or come guidance classes, online classes will continue during this entire month. I mean up to last date of this month, right? Even they can proceed further, but up to this month they will continue, right? And during this month I will try to cover up three important books that are nuclear and particle physics, which is almost complete. Nuclear and particle physics. This book course is almost complete. In one or two lectures I will finish it, right? Then after I will go to solid state physics, right? And then after I will go to electronics. So these are the three courses that I think I will cover up during this month. At the end of this month, I am hopeful that I will cover up. If it requires some additional lecture, then I can continue it after this month also. Right now, some student has told in the message box that they have their entrance examination in the first week of June, right? And how much syllabus they have to cover up, right? What are the important books in physics? So I want to tell all of you that if you are going for MSc entrance examinations, whether it is of Himachal Pradesh University, Sardar Patel University Mandi, or Punjab University Chandigarh, or some other university, if you cover up three important books, right? I'm not saying that these three books are enough. You don't need to go to the other courses, but these three courses are the core of entire physics. And in my experience and opinion, around 40 to 50% questions are asked from these three courses. So if you make command over these three courses, then up to 40 to 50% questions you can do quite easily, right? The rest of the books that you have to cover up, you have to cover up all the UG books, whether it is classical mechanics, whether it is electricity and magnetism, waves and optics, statistical and thermal physics, right? But the question asked in the competitive exams, particularly for the MSc entrance examinations, they are mostly asked from the final year books. And in most of the universities, the final year courses contain nuclear and particle physics, solid state physics and electronics, and quantum physics, right? Quantum physics, yeah, quantum mechanics, right? Right, quantum mechanics. So these are the four core courses of the entire physics that we must learn or understand properly. If we are going for any entrance examination, we must have command over these four courses. But if you cover up the four courses, I think 60% of the questions will be covered. The rest courses contribute 40 to 45% only, right? So in my classes, we have limitations of time, right? So in these online classes, I will try to cover up these three courses. If time is left and I somehow finish these courses well in time, then I can think about going to the quantum mechanics. But one thing is sure, that I will cover up these three courses in details. In the same way in which I am doing nuclear and particle physics, I will go to solid state physics and then I will go to the electronics. Right now, some of the students have asked that which books or study material they should follow. So I want to tell them one thing, that there is no specified book as far as nuclear and particle physics is concerned, that you can go to that book and learn all the things. If I talk about myself, then I concern different books, lot of books before going into any lecture or before going into any conclusion. So all the books are available in our college library. If someone want to assess these books, then that person come to the library and assess them, right? If I talk about the books that are good for nuclear and particle physics force, then we have a book of DC Tile, right, for the nuclear and particle physics. I am also following a book that is nuclear and particle physics. It is I think of the publication of BPC, right? This book I don't, Vishal Publication Company, BPC. I think this book is not available here, but you can search it. It is basically a book of UG level. But if you want to have deep understanding of the concept of nuclear and particle physics, then I told you, then you can go to different books like DC Tile book of nuclear physics, right? And even you can go other books which are available, right? But the thing is, if you want to get clarity of any topic, then you have to go to the different material that is available there, and then after you can draw any conclusion or any clarity of that topic, right? So now I'm coming to the main thing, that is the topic of the day. The topic of the day was some questions related to the topics that I have covered in the yesterday's lecture. So the first question is, the activity of a radioactive sample is decreased by 75% of the initial value after 30 days, right? The half-life of the sample is approximately, we know very well the formula for the half-life, T half is equal to 0.693 upon lambda. So in order to calculate the value of lambda, we have T half, we should know what is the value of lambda. Lambda is what? Disintegration constant, right? But are its units? Per second, per minute, per year, right? Matlab per unit time, right? This is the unit for it. And one thing that I want to tell you, that the disintegration constant is an inherent property of any material. So the half-life period of any radioactive material is also inherent characteristics. It can't be altered, it can't be changed under any given physical condition, whether it is temperature, pressure, radiation, anything can't change this. So every element in the periodic table that is radioactive has a fixed half-life time, and that depend upon the value of the disintegration constant. So in this numerical problem, you are also given that you may use log of 3 is equal to 1.1, log of 4 is equal to 1.4. Now I am taking the relation of activity. We know activity is equal to lambda into n, right? This is one thing. We also know that we have a relation n is equal to n naught e raised to power minus lambda t, right? So from this relation I can write lambda is equal to 1 upon t. If I simplify it, then simply I will get log of n naught upon n, right? So if I replace this n naught upon n by this relation by activity, they are writing r here for the activity, then obviously it will become, because you can see here there is a direct relation between a and n, activity and the number of nuclei in the sample, right? So you can replace it, lambda is equal to 1 upon t natural log of r naught upon r. R represents the activity. They are taking it r, I am taking it as a. So you can write here a also. So then you can see from here that they are giving that the activity of the radioactive sample is decreased to 75%. 75% means 3 by 4 of r naught. 75% meaning this, right? R naught into 75 upon 100, right? So 3 by 4 R naught. So now I can put the value of R here, right? You can see here lambda is equal to 1 upon T, R naught upon R. T is 30 days given, right? And R is what? 3 by 4 of R naught, the reduced activity. Then after simplifying, R naught get cancelled, we got 1 upon 30, natural log of 4 upon 3. It becomes log of 4 minus log of 3, right, into 1 upon 30, right? Log of 4 is given here, 1.4, and it is 1.1. So when you will put these values, you will get 1 upon 100, right? 1 upon 100 is what? It is lambda. You put the value of 1 upon 100 in the relation of T half, so you get 69.3 days, right? So this is the answer. So in this question, the relation for the activity has been used. Activity and the radioactivity decay law, n is equal to n naught e raised to power minus lambda t. So this was the question asked in IIT JAM exam, right? So you can simplify this question. Usually in radioactivity, the question is asked related to either activity, half-life or mean life, right? Now I am going further. I am going to the next question. You can see here 27 cobalt 60 is a radioactive nucleus with half-life 2 log of 2 into 10 raised to power 8 second. The activity of 10 gram of this in disintegration per second. Now they are asking about the activity. Activity again, A is equal to lambda into n. So what I require, first of all, I require lambda. So lambda, from where I will get it? T half is equal to 0.693 upon lambda. So lambda is equal to what? 0.693 upon T half. I will get it from where I will get n. So n is what? 10 gram. The activity they are asking 10 gram. So if I use the mole concept, we are giving this nucleus that is 2760. So 60 gram of cobalt, right, will contain how many nuclei? 6.023 or into 10 raised to power 23. That is Avogadro's law, right? Now 60 gram contain this, then 1 gram will be 1. You can say, you can use 6. They have used 6 in the calculation in order to make the these calculations simplified. 6 into 10 raised to power 23 upon 60. Then 10 gram. 10 gram, they are talking about the 10 gram. So the number of atoms or number of nuclei in 10 gram, so that will be multiplied by 10, right? So you can see here now n, they are calculating n. So n is given as a 10 upon 60, right, into 6 into 10 raised to power 23. You can see from here, right? So it is 10 raised to power 23, right? So this is the advantage of using 6 here. If otherwise you use this value, then the calculations will become difficult. So you have to approximate. So now I got n, the number of nuclei, right? That is equal to 10 raised to power 23 in 10 gram of 27 cobalt 60. Now what is the half-life? So I told you, then I can calculate the value of lambda by using this relation. So they have used 2 natural log of 2, right? Then into this. I think they have not given the value of natural log, but I think they should have given it, right? 2 log of 2, right, into 10 raised to power 8. Right? The question was 2 log of 2, but I think log table is allowed there, so you can see the value. So you can put here the value, all values. This is this. Then after simplification, you got this, right? Lambda is equal to 5 into 10 raised to power minus 9 per second. Now you can put the value of lambda and n, right? So after putting these values, you will get this and this. 5 into 10 raised to power 14, right? So this is the answer. 5 into 10 raised to power 14 disintegration per second, right? Obviously, the answer is disintegration per second. Activity is represented as disintegration per second, right? Number of nuclei decaying per unit time. So this is the answer and this is the way. Again, the same relation, R is equal to lambda n or A is equal to lambda n. You can say that is used, but in all these questions, the important point is that we have to calculate the number of nuclei, and we have to calculate these number by using this concept, mole concept, right? That is when you are given 27 cobalt 60, it means 60 gram of cobalt is equal to this much number of atoms or nuclei, right? So obviously 1 gram is equal to this upon 60, 10 gram is equal to multiplied by 10, right? So this is the way, right? So Avogadro's law and this mole concept is used here, right? So now this is the next question. So I'm going to the next question now. So well, now I'm coming to the next question. You can see it on the screen. The atomic nucleus X with half-life Tx decay into a nucleus Y which has half-life Ty. The condition for secular equilibrium is. Now, I think I forget to cover this topic in yesterday's lecture. This question is from successive transformation and radioactive equilibrium. Successive transformation and radioactive equilibrium. Right. So in this topic, actually, successive transformation means when we have a chain of radioactive decay. I mean, nucleus A is decaying into nucleus B, then it is decaying into nucleus C, then it is decaying into nucleus D, and finally it is arriving at a stable end product Z. This is called as successive transformation, right? Successive means each of the member of the chain is decaying into another member. This is called parent. This is parent nucleus, daughter, granddaughter, then grand-granddaughter, and so on. Let the decay constant or disintegration constant for this is lambda 1, for this is lambda 2, for this is lambda 3, for this is lambda 4, and so on, right? So this kind of radioactive decay is called successive transformation. Now, in successive transformation, we come across a radioactive equilibrium that I talk about here. So radioactive equilibrium means if this process continues for a long time, then a equilibrium kind of condition is reached. In this condition, the rate at which, for example, this nucleus is decaying is equal to the rate at which this nucleus is getting produced by the decay of this nucleus, right? This is called radioactive equilibrium, right? Once again, I'm repeating, the equilibrium means the rate at which a particular nucleus, for example D, it is decaying into another nucleus. It is equal to the rate at which this is produced, and it is produced because of the decay of C. So this is called radioactive equilibrium. Now in this article we have two type of equilibriums. One is secular equilibrium and other is a transient equilibrium. If we talk about the secular equilibrium, so in secular equilibrium we consider that lambda 1, right, the disintegration of the parent nucleus is very small as compared to lambda 2. So lambda 1 is very small as compared to lambda 2, and with same way lambda 1 can be taken equal to 0. So the equations that comes after doing the mathematics of this entire article, I'm not going to that. We apply the condition that lambda 1 is very less than lambda 2 and lambda 1 is taken as a 0. So in that case, whatever condition we got, the condition we got is a n1 lambda 1 is equal to n2 lambda 2 is equal to n3 lambda 3, so on. This is the condition of secular equilibrium. Now but the question that they have asked about the relation between the half-lives, right? So you can come to the half-life. We know very well that half-life for this will be Ta will be 0.693 upon lambda 1. Similarly, for this Tb is equal to 0.693 upon lambda 2. But here lambda 1 is very small as compared to lambda 2. It means if it is very small, it means Ta is very large as compared to Tb. So this is the answer to this question. You can see here, this is the question. Here instead of A and V, they are taking X converts to Y, then converts to Z, then so on. So Tx should be very greater than Ty. This is the correct answer, right? So this is very important. Secular equilibrium. Similarly, if I go to the transient equilibrium, right? Second condition, transient equilibrium. So in transient equilibrium, we consider lambda 1 less than lambda 2, but we don't take lambda 1 equal to 0 as we did here. This condition is not utilized. So when we simplify this, then in that case we got n2 upon n1, right, is equal to lambda 1 upon lambda 2 minus lambda 1. This is the condition for a transient equilibrium. We know very well that all these are constants. So we can say n2 upon n1 is always equal to constant, right? So this type of a condition or this relation is known as a transient equilibrium, right? So we must know both kind of equilibrium, secular equilibrium and transient. Secular equilibrium is there when lambda 1 is very less as compared to lambda t, and we can take lambda 1 is equal to 0 in the equations. We arrived at the result n1 lambda 1 is equal to n2 lambda 2 is equal to n3 lambda 3, so on. In the other case, transient equilibrium, lambda 1 is less than lambda 2, but it is not equal to 0. And we have this relation, right? So in this relation, we can say it is equal to constant. So this is the condition of transient equilibrium, right? Now I am going to the next question. In a typical human body, the amount of radioactive potassium 40 is 3.24 into 10 raised to power minus 5% of its mass. The activity due to this K40 in human body of mass 70 kilogram in kilobecquerel. So again, activity R is equal to lambda into N, right? So half-life is already given, so we can calculate the value of lambda from there, right? Avogadro's number is given 6.022 into 10 raised to power 23. In earlier, that question I have taken 6, so here they are already giving 6.022, right? Now we have to calculate the value of N, right? Again, what I told you. So in order to calculate N, now they are saying that the amount of radioactive potassium is this percent of its mass, means 70 multiplied by 3.24 into 10 raised to power minus 5 upon 100. This whatever equation, whatever number we will get, they have, I think, simplified it here, right? You can see. And 70 into 3.24 into 10 raised to power minus 20, minus 5 divided by 100. This is the mass, right? Now we have, actually this is the mass of what? I can say, right, mass of K40, that is equal to this number, right? This number 70 into 3.24 into 10 raised to power minus 7. I am taking it upside, so I can say 7 into this 3.25 into 10 raised to power minus 6. This is the number, this is the mass. Now I have to calculate the number of nuclei in this mass, right? So again, what is the formula? Formula is mole concept, right? So they have calculated it. So how we will calculate? Again, this 40 gram is equal to 40 gram is equal to how many? 6.022 into 10 raised to power 23. I think they forget 23. Then 1 gram is equal to 6.022 into 10 raised to power 23 divided by 40. Then this one, right? This much of this much number that I have calculated here, right? This much is equal to, obviously we will multiply it with this, but they are doing all these things here. I have already calculated it. So 7 into 3.25 into 10 raised to power minus 6 gram will be equal to what? Number of n is equal to 7 into 3.25 into 10 raised to power minus 6, right, divided by 40 into 6.022 into 10 raised to power 23. What they have done here, they are doing all these calculations here, right? 3.244 24, it was 24. I think here I have written 24, right? So this is the 24. This is the number of nuclei. So what was the equation? R is equal to lambda n. Put the value of lambda, right? Lambda is equal to 0.693 upon half-life. That is already given here, right? This is right. So you put all these values and then you can do the simplifications, right? You will get 6.0 into 10 raised to power 13 disintegration per second. So they are asking in kilo vacuole. We know very well 1 vacuole is equal to 1 disintegration per second. I told you in the early lecture. So it will become 6 into 10 raised to power 10 kilo vacuole. So this is the answer to this question. So again, but what knowledge was required? The knowledge required was the one relation R is equal to lambda n, how to calculate the value of lambda, how to calculate the value of n. In almost all such type of questions, we have to calculate the n, the number of nuclei in the sample, and it is calculated by using the mole concept and Avogadro's law. And that states that if this nucleus is this element is given, it means 40 gram of potassium is equal to 1 mole, and 1 mole is equal to 6.022 into 10 raised to power 23, right? So in this way we can calculate the number of nuclei, right? So these were some questions that I have talked about here in the lecture, and I have seen other competitive exams. So mostly questions are asked from these topics, right? Now I am showing you the books that I talk about. This is DC Tile book, right? It is from Himalayan publication. So you can even purchase this book, right? It is a very good book for the nuclear physics. Other book that we can follow, it is of Tata McGraw Hill publication, Concepts of Nuclear Physics, and it is by Bernard Cohen. It is also a very good book for the nuclear physics, right? So these are the two books that are extremely good. You can even use these books for the PG level study also. But as far as UG level study is concerned, I'm also following this book. As I told you that this book was written by Kulwant S. Thind, Manmohan Singh, Vijay Kumar, right, Leaf Greward, and it is of a Vishal publication company, right? So if this book is available to you, then you can also follow this book. It is also a good book, right? But other books which are available in the market that normally followed, right, I don't prefer these books because there are a lot of mistakes in these books. So I think I have answered all your questions. So thank you very much.